Okay, coming to the next problem that I have here, which of the following represents a realistic wave function of a particle? A realistic wave function by means I means acceptable wave function. Okay, we have to find out that whether this in the example is a realistic or not realistic. Okay, in the solution I have to, okay, first of all I have to tell you something about the condition of the acceptable wave function. For the acceptable wave function, it should be normalizable, okay, continuous, square integrable, okay, should not discontinuous in like finite limit. Okay, vanish at infinite limits. This one and this one is really the same thing. Okay, so we have just to calculate, we have just to remember these 5 points and we have to apply to all of these things. Okay, so first let's say a psi of x is given as any normalization constant e to the power x square upon a square e to the power iota kx. Okay, you can see here at x tends to infinity, it becomes infinite. Okay, so it is not an realistic wave function. For b, let's say psi of x equal to a e to the power mod x upon a e to the power I kx. So it means it is a e to the power x upon a e to the power I kx for x less than 0 and a e to the power negative x upon a e to the power I kx for x greater than 0. So you can see at x tends to negative infinity, e to the power negative infinity will be 0 and the wave function vanishes, and here x tends to infinity, e tends to negative infinity and this will be 0, so it vanishes at infinite points and it is square integrable. That's why it is realistic. Next is psi of x is a sine of x square. So we should not just, we can look at this function and it has discontinuity at x 0. Okay, if we put 0 at x equal to 0, it becomes infinity. So a sine 0 upon 0, so it is not continuous. Okay, it discontinued at x tends to 0, that means it is not a realistic function. It should not be discontinued at finite limit, as I mentioned here. Okay, the next is psi of x equal to a e to the power negative x upon a for x greater than 0, a x e to the power x upon a x less than 0. Okay, okay, so you can by just plotting you can also write at x less than 0 and x greater than 0, so it will be e to the power negative x function for x greater than 0. Okay, negative x function like this, and here also like